Hey, pre-calc students, Mr. Mitchell here. Hope everything's going well. We're going to take a look at multiple angles and product to sum formulas today. So let's go ahead and get into it. So we're going to find all the solutions of 2 cosine x plus sine of 2x. All right, so we have some issues that we haven't had before. Here's a multiple angle, which if that were just the only thing, we could solve that. But the fact that we have 2 cosine x here, we can't. So we have some formulas that are double angle formulas. So let's take a look at those. So in our formula sheet, we have a lot of formulas in this section that we're going to talk about, but here we're focusing on our double angle. So we have the sine of 2u, we have the cosine of 2u, and we have the tangent of 2u. So there's our double angle formulas. Okay. So we're going to try to use this one here. The sine of 2u equals 2 sine u cosine u. Okay. So really what we're trying to do here, we got cosine of 2 cosine x plus, and we want to use our formula 2 sine x cosine x. And that equals 0. Okay. So there's your identity, your formula. So now we just try to work to solve this. Okay. So you might say, well, how are we going to solve this? Well, think about some of the algebra we could do. We have a 2 here and a 2 here and a cosine and a cosine. Why don't we factor out a 2 cosine x? If I factor out a 2 cosine x, I'm left with 1 plus sine x. And all of that still equals 0. So then we just set each piece equal to 0. So 2 cosine x equals 0. And then 1 plus the sine of x equals 0. So if you divide both sides by 2, cosine still equals 0. And then if you subtract 1 on both sides, the sine of x equals -1. So where does the cosine equal 0? That happens at pi over 2 and 3 pi over 2. Again, our unit circle is still coming into play here. And then it does want all the solutions, so we need to add 2 pi n onto here. All right. And then we also want to know when the sine is equal to -1. Sine equals -1 at 3 pi over 2. And then you add your period on here. We actually don't have to write this one over again because it's already included here, but it's not wrong to say that. But technically, I don't have to write it out twice. Okay, so there's my double angle formula in work. All right. Okay, so the next question, use the double angle formulas to rewrite and graph the equation over the interval. So could we just type this into the calculator and graph it? Absolutely. Okay, but they want us to convert this into a double angle formula of some kind and then be able to graph that. Okay, so we have our cosine squared double angle formula possibly. All right, so let's go to our formula sheet. So we have some cosine. Now this, we're going to use the formula backwards. So I think we have something that looks like this. All right, so let's again go look at it. So it's 4. So what if we were able to factor out a 2? So what I'm trying to do is make it look like one of those formulas. Okay, so if I factor out a 2, I got 2 cosine squared minus 1. 2 cosine squared minus 1 is what I have. So that equals the cosine of 2u. All right. This is just saying this can equal this or this or this. So for right now, converting it into one of these two would not be helpful. We're trying to graph it. We know how to graph sine, cosine, and tangent when they're to the first power. We don't know how to graph by hand anything that's squared. So that's why we want to convert this into this. Okay. So what we have here is y equals 2 cosine of 2x. Oops. And so now we want to try to graph it down here. So this 2, remember, is going to change my amplitude. And what that's going to do, it's going to make it go up to 2 and then down to -2. All right. And so we're still going to have mountain, valley, mountain. And notice I can make my own scale down here, which is kind of nice, but there's no vertical shifts and there's no horizontal shifts. It's just a period change. The normal period is 2 pi over b. So b is 2, so my period is pi. All right. So really what I'm looking for is to draw, if we were going to go to pi, and then this is 2 pi, and this is pi over 2, and then this is 3 pi over 2. So what we need to do, we need to get mountain, valley, mountain in that same time frame. Okay, so we need to have a mountain, a valley, and a mountain, and then it repeats itself. It's going to come through here in the middle. So really, this is what my graph is going to look like. Again, normal graph, this would have gone, we'd have had a mountain, a valley, and a mountain if the period hadn't been changed. Okay, so that's how you convert using a double angle formula, and then that's how you graph, a little bit of review of graphing there. Okay. So now we have to take a triple angle formula and turn it into terms of sine. Okay, so really we can't just use a formula that's a double angle formula right now. What we have to do is try to separate this into a couple different things that we just got done learning about. Is our double, if we can make it into a double angle and a single angle, then I think that's what we want to do. If you notice, this is a sine sum formula. Okay, so if I go to my formula sheet, and here's the sum and difference formula. Okay, so we want to try to use this formula here. Okay, so we're going to have the sine, cosine, sine, or cosine, sine. So using this, oops, we're going to have, I'm not sure why it's not cooperating, but that's all right. We're going to equal the sine of x, sine of 2x, sorry, the cosine of x, plus the cosine of 2x, sine of x. Okay. And now we need to try to use some double angle formulas to make things work. So here's the double angle formula. Again, if I go to my formula sheet, double angle formula for sine, so it's 2 sine cosine. So this is going to be 2 sine x, cosine x, cosine x, because this cosine we didn't do anything with. This cosine came from the formula. So this little part right here is from the formula. And then we need our double angle for the cosine. All right, and you might ask, well, which one of those are we supposed to use? Well, which one, what are we trying to do here? We're trying to get things in terms of sine. So my double cosine angle, I don't want to have this because it still has cosine in it. I don't want to have this because it still has cosine in it. Here's the one I want to use. 1 minus 2 sine squared u. So this is going to be 1 minus sine squared x, and then times sine x is also right there as well. Okay. So I did make a little mistake. I forgot my parentheses around this. This is all multiplication here, right? Times, this whole thing. So I want to do a little simplifying here. I want to get this as cosine squared. And then I want to distribute this. So this is going to be sine x minus sine cubed x. Okay. And then we're getting closer because remember, we're trying to get it in terms of sine of x. All right. And that can be cubed. That's okay. So now I need to get rid of this cosine squared. Well, if you remember, cosine squared is 1 minus sine squared. So let's distribute. So 2 sine x minus 2 sine cubed x. So again, we're just combining some like terms here. So notice the ones that have the same power we can put together. So this is 2 sine x, and sine x give me 3 sine x. And negative 2 sine cubed of x minus sine cubed of x is minus 3 sine cubed of x. And I think you could do some other simplifying. You could pull out a 3. You could pull out a sine out front. But I don't know that we need to do that necessarily. I think we're good to kind of leave it the way it is. All right. All right, let's take a look at the power reducing formula question. All right, so rewrite sine to the fourth as a sum of first powers of cosines of multiple angles. So we're not allowed to have any exponents that are higher than 1. There's obviously always going to be exponents of 1, but no exponents of squared, cubed to the fourth. Okay, so we're going to take a look at, here's our power reducing formula. Now we have something to the fourth, but we only have squared powers, power reducing formula. So we're going to use this one. We're trying to get everything into cosine. So 1 minus cosine of 2u over 2 is what we're going to use. So really what we have here in terms of the sine, this is really sine squared squared. Okay, so really this is the power reducing formula. It's 1 minus the cosine of 2x all over 2, but then that's squared. Okay, again, we're using this formula here, and we're going to actually use it a couple times. So we have to do a little bit of simplifying now. So be careful. You can't just square the terms here. So what we have to do is write this out. We have to write this out twice. And then we're going to have to do FOIL. Because that's what this is. When you square something, you actually have it twice. So if we do FOIL this, all right, you get a 4 on the bottom. So you're just multiplying across the top and across the bottom. Across the top, you have to FOIL your first. And then when you do your inner and your outer, you get negative 2 cosine of 2x, right? This is negative 1. This is negative 1 of cosine of 2x. So you have negative 2. And then when you multiply this, that last terms, you get plus cosine squared okay. So I don't necessarily think you need the exponents, or I'm sorry, not the exponents, but the parentheses, but you do need that exponent there. I made a little mistake. This is supposed to be a 2. When you multiply, you don't change the inside part. This is still just 2x. All right. So now we have reduced it, but we haven't gotten rid of it. Notice we still have a squared. Okay, so we're going to use the power reducing formula again. If you want, you can try to pull out a 4, or you can leave it the way that it is right now. That's kind of your call, how you want to simplify. If you don't like complex fractions, you want to pull that 1/4 out right now. If you don't mind it there, then you don't have to do anything with it yet. So I'm going to just leave it alone for right now. But then I'm going to deal with my power reducing formula here again. So I don't want to have cosine squared. So I need to look at my formulas. So here's my, when I have cosine squared and I want to reduce that, it's going to be 1 plus the cosine of 2u over 2. Well, remember, there's already a value here. This is why I was thinking ahead of putting the 4 in there. This is going to end up being a 4x because there's a 2 in the formula, and then there's already a 2 in the question. All right. So this is going to be 1. This is going to be 1 plus the cosine of 4x over 2. All right. So now we have a complex fraction. I know some students, they really don't like that. If that's what you could have pulled this 4 as a 1/4 out front sooner. Okay. Or you can simplify it here at this point. Okay. So at this point, let's try to get rid of our complex fraction. Let's divide everything by 4. So when I divide everything by 4, I get 1/4. minus 2 cosine of 2x over 4. And then that's plus, that's going to be an 8 on the bottom. Okay. So all I did was just divided everything by 4. So now I don't have a complex fraction. I have 3 fractions. So we can go through and simplify some things. I do need to still divide this up. Sorry about that. I do need to divide this up. This is 1/4. I can't do anything about that. This, I can actually simplify this 2 and this 4. This is just going to be the cosine of 2x over 2. And then over here, divide both of these things by 8. All right. And then you're almost done. It would depend on how you'd want to show your answer. If we're allowed to have multiple fractions, then we're almost done. If we had to put it all into one fraction, I wouldn't have simplified this in the first place. But so this piece is done. What's 1/4 and then 1/8? I want to try to put those together. So this is 2/8, right? So this is going to be 3/8. And then this is that. If we had to get them all over one fraction, we could get an LCD here. But then again, I wouldn't have simplified that. So because the directions are what they are, I am done. And notice I don't have any higher powers. Everything is to the power of 1. Yeah, we have multiple angles, but that is okay. All right, we're allowed to have multiple angles. So now we need to find an exact value of the sine of 105. All right, we don't know what that is exact. I can type it in my calculator, but it's not on the unit circle. So we're going to use a half angle formula. So let's go check those out. So here's my half angle formulas. Yes, sine and cosine got square roots in them. So what we're trying to find here, we're trying to find u over 2. All right. So if we can, and you're going to use a half angle formula, if you look at what you have, can you double 105 and have it be something that's on your unit circle? So 105 times 2 is 210. Is that something on the unit circle? Yes. So that's why I would potentially use my half angle formula here. So u over 2 is the formula that we're using. All right. So here it's plus or minus. It's not, you're not going to keep plus and minus in your answer. You're going to have one or the other. All right. So plus or minus the square root of 1 minus cosine over 2. All right. Just want to double check. Yes, we're good. So now u is 210. U over 2 is 105. That's what we're trying to find here. So we're trying to find the sine of 105. So I need to do 1 minus the cosine of 210. All right. So what's the cosine of 210? Well, if you're not very good at the unit circle with degrees, you can always think about it in terms of radians, or if you know what it is, that's fine too. This is pi over 6 angle. Okay, so what's the cosine of anything pi over 6? It's the square root of 3 over 2. And we are in the third quadrant, so it's negative. All right, so still trying to find the sine of 105. Still equals plus or minus. We'll worry about that later. So now we need to work on trying to add these two fractions together. So it's going to be 1 plus the square root of 3 over 2 over 2. And so let's divide. We could divide both of these fractions by 2. So that's 1/2 plus the square root of 3 over 4. Okay. And then our sine of 105 equals plus or minus. Now we put these together. LCD is 4. So this is, we have to change the top here to 2 fourths. We don't have to change the top there. So this is the square root of 2 plus the square root of 3 over 4. All right. And I know I'm running out of space here, but that's okay. Sine of 105 equals plus or minus square root of the top. What's the square root of the bottom? Is 2. And then last thing that I always like to do is I have to figure out whether it's positive or negative. It's not going to be both. We keep the plus or minus. You could figure that out like right now at the very beginning, or you could do it at the end. It doesn't matter. Where is 105 at? It's in the second quadrant. So where is sine positive or negative in the second quadrant? It's positive. So my answer is positive. Okay. So let's take a look at this one. We're going to find all the solutions over an interval. Okay, so we're not going to need to do pi n or anything like that. Okay, so we have a half angle formula here that we're going to have to deal with. So we're going to copy down the rest of this for right now. And I need to deal with the cosines. It's squared. So really everything that I have for the half angle is going to be squared. So if I go take a look at the cosine half angle, it's really this. Okay, so I'm going to replace this in my question with this. So it's plus or minus the square root of 1 plus the cosine squared. So it's plus or minus, which is just going to go away. Then it's 1 plus the cosine of x over 2. All right, so now we have to square this mess. So the plus or minus goes away, all right, and the square root goes away. So you're just left with this piece. And then the 2 is going to cancel with that 2. And now we have to ask ourselves, we have sine and cosine in our problem. We have to ask ourselves, is it easier to convert cosine into sine or sine squared into cosine squared? All right, so we're going to convert this into 1 minus cosine squared, because it is much easier to convert the squared one using the Pythagorean identity, right? We've used that a lot. So let's simplify. So you're going to have 2 minus 1 plus the cosine squared equals 1 plus the cosine of x. And we'll go over here. So let's just simplify here. So that's going to be a 1 plus the cosine squared of x, 1 minus cosine of x. Let's bring everything over here since it's positive. Cosine squared. Notice the 1 is going to cancel with that 1. And that should be a negative. So I set it equal to 0. Now I just need to factor. All right. So we're going to factor out a cosine. I'm going to have cosine minus 1 equals 0. And now I'm going to set each piece equal to 0 here. And so where does the cosine equal 0? At pi over 2 and 3 pi over 2. And I'm not worried about pi n's here, or 2 pi n or anything like that. And then the cosine of x equals 1. Where does the cosine equal 1? At 0 and then 2 pi. But if I look at my directions, I'm only going to 2 pi, but not including 2 pi. So I don't put 2 pi here. So my answers are these 3. I got 0, I got pi over 2, and then I got 3 pi over 2. Okay. Now we're going to take a look at product to sum formulas and sum to product. So that's a whole nother type of formula. All right. And I'm going to record that in a second video. All right. So see you in a little bit.